So in this video, we're going to look at question number 8, exercise 1C. An aeroplane accelerates from rest along a runway at a constant rate of 4 meters per second square. It needs to reach a velocity of 80 meters per second to take off. How long the runway needs to be? So it accelerates from rest. So your initial velocity is 0. And the acceleration is 4 meters per second square. And just at takeoff, the velocity needs to be 80 meters per second. So your final velocity is 80. Okay, so how long the runway needs to be? Basically, you have to find some sort of distance. Okay, so you use which formula? So there is no time actually. No time is given, and also you don't have to find any time. So naturally, this formula looks good. So v square equals to u square plus twice as. So 80 square is equal to 0 square plus 2 into 4 into s. So you have to find the value of s, and the value of s is going to be equals to 800. Okay, simple. Now let's say use some other formula. You have v, you have u, you have a. So let's say, so this sum is done, but let me look at some other way. Let's say you just started with some other formula. So the way I just showed, that's the optimal way, but you could solve it by taking another path also. So let's say you just use this formula in the beginning. V equals to u plus 80. You're using this formula. V equals to u plus 80. So your v is equal to 80 u plus a t. So you find the value of the time. The value of t is equal to 20. So that is actually, so how long from the rest position it takes to reach the final velocity just before takeoff. So now you have the time actually. So now how you can find the value of s? So using this time, so I can use this formula or I can also use this formula. Any of these two formulas we can use. So let me use this formula, and you can try by yourself using this formula. The answer has to be the same. U plus v by 2 into t. So 0 plus 80 by 2 into time 20. So the answer will be the same, 800. Even if you use this formula, the answer is going to be 800. And you have to understand that initial velocity is 0, final velocity 80. So u plus v by 2, the average velocity has to be 40 meters per second. Done. So now let's look at question number 10. A driver sees the traffic lights change to red 40 meters away when it's traveling at a velocity of 30 meters per second. To avoid wasting fuel, he doesn't brake but lets the car slow down naturally. The traffic lights change to green after 12 seconds at the same time as the driver arrives at the lights. After 12, okay. So find the speed at which the driver goes past the lights. Part A, and part B, what assumption have been made to answer this question? So your S, the value of S is given, that is S is equal to 240, and the initial velocity is given as 30 meters per second. And the traffic lights change to green after 12 seconds, the same time as the driver arrives at the light. That is, he sees red, so he doesn't brake, but he's now lets the car slow down naturally, that he's not pressing on the accelerator. So it takes him 12 seconds to reach the lights, and at that time the light turns, just at that time the light turns green, and it takes 12 seconds in this process. So the value of time is equal to 12. So you have to find the speed at which the driver goes past the lights. Okay, so basically what? Basically you have to find the final velocity. Okay, so you have a bunch of formulas. you can use any one of them. So one thing is that your acceleration is not given. So naturally, we will not use the formula which has acceleration. Acceleration is not given, and also acceleration you don't have to find out also. So which formula works best? This formula. There is no acceleration term here. So use this one. So S is equal to 240 half U plus V, that is 30 plus V into time is 12. So the value of V, you actually get it as is equal to 10. So basically these are the values that are given. So you see that no, there is no acceleration term is not involved in this question. That is, you don't have to find it, or actually also it's not given also. So you see that using this formula in one step we can find the velocity, final velocity. Okay, so let's say you don't use this formula, use some other formula. Let's see, you just start with, so this sum is done in the optimal way. So let's see, you use this formula. Start with S equal to ut plus half at square. So in that case, actually, if we S equal to ut plus half 12 square, so ut plus half at square. So you'll find the value of A actually from here, and actually you have to keep in mind that the value of A is definitely going to come as negative. So after you find the value of A, then you can insert in this equation, V equals to U plus AT, to find the velocity. So this also you can do in two steps. So I'm just showing it to you so that you're very much familiar with using the formulas and you get very comfortable with it. And now 10b, what assumption have you made to answer the question? So we have actually assumed constant deceleration or constant acceleration. So here the car is decelerating, so the value of the deceleration is constant, because otherwise we will not be able to use the Shubert equations.